Hi, this is Wes Weimer, and this presentation covers easy Amazon EC2 file transfers with the SSHFS concept, as well as some hints for not losing work. It's going to be fun. Quick outline. We're first going to talk about using SSHFS, stands for Secure Shell File System, to make your EC2 remote files look just like any other local Windows or Mac folder. Then we'll talk a bit about running programs locally versus remotely. For this class, you want to run them remotely to make sure you get the right answers. Give some hints for downloading big files directly to EC2 using utilities like wget. We'll talk about running programs remotely without losing your work if you're disconnected, which is great because students sometimes close their computers, they run out of power, the network might go down, and you don't want to lose any work for a long-running job. And I'm going to be presenting this using the Windows version, but you can get all of these same outcomes on a Mac. So the first thing we want to do is make sure that we can SSH into our remote EC2 instance normally. And so we'll just double check on Amazon, get the instance information, try to SSH there. If this part doesn't work for you, you'll want to review the homework 0 setup steps on Amazon EC2. So I'm just going to go to our EC2 dashboard, look around and find the description of instances. Click there. I've got one instance running associated with this class. I'll just click on it to make sure I'm getting the information from it. And it tells me its IP address. And I'm just going to copy that IP address. And then let's say, close Zoom. Let's say we have a command prompt already open, or a shell prompt if you're on the Mac. Open to my home directory. I can use SSH. I use -i to give it my identity key file. For me, that's on my desktop, and it's called eeks481.pem. Give it the name of the user on the remote system. That's Ubuntu for me. And then I just paste in that IP address. And it worked. So now the prompt is changed to indicate that we're running Ubuntu at this remote location, and I can run normal Unix shell commands. I've already created a small test Python program, but let's just show editing something remotely with a text editor like Nano. Here I've got a Python programming program that says I'm running, and then 600 times it prints out a number and goes to sleep for a second. Let's just make a change to this to show that we can. I edited this file remotely. All right. And I will save it. And now I could run it. And it says I edited this file remotely. I'm running at this remote location, and it's printing out all of these numbers. A long running task. All right. We'll just quit out of that and exit out of the uh, remote instance, which is still running in the background, but I would have lost any of that work or that program's no longer running. And let's go back to our presentation. And now we want to set up something that will make that remote file and any others I end up transferring there later look just like a native Windows file. And so we're going to use SSHFS for Windows. And on modern versions of Windows, there's a wget package manager, sort of like apt or whatnot. And we can just ask it to install this utility for us. So I'm going to go back here and just paste that in, wget install sshfs-win, sshfs-win. Now for me, I already have this installed. So it's going to go through all of the steps, and then at the end, it's going to say, you already have this installed, blah, blah, blah. It didn't install this time. But for you, you'd get the whole thing. So Microsoft has found the package. It's asking me for security. And then this 1603 just means that for me in particular, it's already installed. So now I want to make sure I have my EX481 PEM key on my desktop. And I did, but we'll just go verify. Here I am in my desktop, and here's my EX481 PEM key that I got from Amazon when I was doing the Homework Zero setup. Okay. I'm now on my Windows shell going to make a directory called .ssh. Note the dot. Now, for me in particular, I already have this directory created, so it's going to say you already have one. But for you, it'll probably just say nothing, we've made the directory. This is a special location where Windows is going to look for our SSH key. Indeed, what we want to do is copy our PEM file into this SSH folder and name it ID RSA. RSA is the name of the crypto system that's used for the secure shell. Now, oops, I may have forgotten to copy this. All right. I've done this step previously to make sure that it works, so it's probably going to ask me if I want to overwrite it. Say yes, we want to overwrite it. Now we've copied the file. So we've taken our PEM file from Amazon and put it in a special location that Windows is going to look for. And now I can make my remote files look just like a local folder on Windows. So I'm going to type //sshfs.k. The K means use my key, use my PEM file that I just put here. /Ubuntu, that's the name of my user remotely at. And then I need to replace this WXYZ with my particular IP address. So for us, that was once again 18, 118, 29, 136. That's specific for me. Yours will be different. So //sshfs.k, Ubuntu, and just go up here and where it says desktop, instead, I'm going to put in //sshfs.k, Ubuntu at 18, 118, 29, 136. Again, your number will be different. I pressed enter. And now we can see that a few different things have happened. One is that I can see files that exist remotely, like my test Python file. Another is that I normally have like a C drive on my computer, maybe a D drive, maybe a remote or a memory stick. But now this extra option has appeared in Explorer. So if I were using my web browser and needed to upload something to the auto grader, I could just select here and get it. And it behaves like any other folder locally. Like I could, for example, copy this test file and just paste it onto the desktop. And now it's a file on my desktop. And also there remotely. So this is excellent. Dragging things back and forth is much easier than using SCP over and over again to transfer them. Just delete the copy from my desktop. So let's talk a bit about, now that I have this sort of transparent local access to my files, running them locally versus remotely. You can take a simple program like this one that's stored on the remote EC2 instance and execute it using your local CPU. Usually, though, this will yield the wrong answers for most of the homeworks. One of the reasons we have you use these EC2 instances is that they all have the same versions of libraries, the same sort of architectural setup, so slight differences in machines won't cause people to get different testing answers. So you want to make sure you're running anything remotely on EC2. But you can still do editing locally. So let's actually say, maybe I really like VSCode as an editor. I could run VSCode, right? And maybe right now it starts by default in my desktop, but I could say, oh, I want to open a new folder, and the folder I want to open is this remote one that's, this Ubuntu machine. I can select that folder, and VS Code can now see my test Python file. Indeed, if I click on it, I see all of the stuff I had before, plus the print statement of I edited this file remotely. Heck, let's add another one. I edited this file locally as well. so convenient. Now, I will save that just to make sure it works, and we can verify. If I go back over to my uh, command prompt window, if I SSH back in, I could run this file remotely, and it includes the line about having edited it on my local machine. I can also run this file locally in VS Code. However, beyond the simplest of testing, we don't recommend that you do this for EX481 because you might get different answers. For example, you see here, this one that I'm running locally says I'm running on Wes's desktop and it's version 3.13.9, whereas this one over here was running at a remote IP address, but it was version 3.12. And so I would hate for any student to miss some easy points on the homework because you happen to be running a different version of Python, that sort of thing. So we'll just exit out of here. But you can do all of your editing in something that you like VS Code, and then just run it remotely on this EC2 instance. So make sure you're running anything big, like configure make remotely on EC2. There is a VS Code SSH extension. And if you Google around for how to do this sort of thing, it may come up. However, as a warning, in previous semesters, many 481 students have reported that the VS Code SSH extensions don't work for them for the particular combination of Amazon EC2 and EX481. Seems like there's a slight bug in this extension. And unfortunately, the failure mode is really insidious. It seems to work at the start, but then it randomly stalls after a while. And when it stalls, the remote instance becomes unresponsive and you have to restart it with Amazon, and then you've lost all your work. And we really don't want students to lose their work. Now, hopefully, eventually, they'll fix this extension bug. But until then, just don't use it. So you could search on VS Code for SSH. Don't do that. Instead, what we've done here has already solved the issue. You're able to use VS Code to make edits as if it were a local file. You can copy things around and you can run them remotely, which is exactly what you want to be doing for EX41. Now that we're gaining a little more familiarity with these remote instances, as another potential hint, you could get a big file from the EX41 website or whatnot, download it to your desktop, and then drag it over to the remote machine. But sometimes that can take a while, especially if there are a lot of individual files involved in that. It's often easier to just get the URL and then have it download to the EC2 instance without going through your local machine. Let's see how that plays out. Well, let's say we go to homework one for EX481, and down here somewhere in the middle, there's a big C program. The reference implementation is available here. I can right-click on it and choose Copy Link. Now, if I go back to my terminal where I've SSH'd into Ubuntu, I can just type wget and then paste in that URL. And it downloads very quickly and says it's created this file libpng targz. Now I have two important files there, my testing Python script and libpng. I can extract from libpng, and now inside there's all of this other stuff that you'll be using in homework one. And it's often much easier to transfer and extract something like this than to download it to your local machine, extract it there, and send all the files over. Indeed, sometimes that causes students to get the wrong answer because not all computers store new line information the same way. So we can just get the location of a link and use something like wget, which stands for like www.get, and paste in the link. So far, all of this works very conveniently, but if there were to be a power outage, or if I were to, be in like a Starbucks and the network goes down, then I would lose any long-running work I have on the remote server. Let's see how that goes. So I have my test program that prints out these numbers 0, 1, 2, 3, 4. And if we watch it for a while, let's imagine these are like files we're testing or files we're compiling or something like that. We got all the way up to 10 or 11 or 12, which is really good. If this had been running for, 10 minutes or an hour, I would really hate to have to restart it from the beginning if I lost it. But if I do, oh no, just close that and then restart a new Windows command. If I try to SSH back in, I'm going to use X41 M key. I'm going to go look up my address. I'm there, but I lost all the work. I don't see those numbers scrolling anymore. I lost them. We really don't want that to happen for students because it can be very frustrating. Turns out there's a single command that allows you to sort of mark a session or store it in a special way so that you won't lose any of your work. It's called the Unix screen utility. After you've SSH'd into your Ubuntu EC2 instance, you just type the word screen and then press enter. It says, I'm GNU Screen version 4, blah, blah, blah. And now it looks like nothing has happened. I'm back at Ubuntu. So let's say once again, I'm going to run my test program. It's doing some work, 0, 1, 2, 3, 4, 5, and I'd really hate to lose this ongoing work. But what if something happens? I run out of power, the network goes down, I lost my connection. Well, let's just start a new one. Here I am, I'm going to SSH, got my 41 key. Now, so far, I'm not seeing the saved work in the background, but we just type screen-R to reattach or resume. Screen-R, and as soon as I press enter here, it's going to be as if I'd never left. You're going to see that now we're all the way up to number 53, 54, 55. Not only did I not lose any work, but it wasn't interrupted. It continued in the background. So I described this as it being saved, but it's really more that it just kept going even though you weren't there to watch it. There are a number of activities in EX481 in the homework that take 10 or 12 hours to run for many students. We suggest that you start any long-running activity after running screen, and then just kind of verify, close the terminal, blah, 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 go back in and make sure you can see it. And then you can close your computer for the night and everything is fine. So I'll just quit that. If for some reason you wanted to leave your screen protected work, you can type exit to get out of screen and it says screen is terminating, but we recommend that students use screen so that if there's some sort of network connectivity problem, they don't lose any long-running work. For more information, you can Google. There are a bunch of videos out there on how to use Unix screen because this is an old utility. Now, I've been showing everything from Windows, but you can also use SSHFS, which is the setup that allowed us to share files back and forth transparently on a Mac. By the way, under Windows, you'll notice that we did extract that libpng bit there, but we don't immediately see it. Sometimes because this is a remote folder, you have to click this refresh button. Oh, look, now there's all this libpng stuff that we extracted remotely. You can get this same sort of convenience on a Mac. The installation steps are different. Like in addition to SSHFS, you might have to install Mac Fuse, blah, blah, blah. But the outcome is the same. Since I'm recording this on a Windows machine, I can't show the Mac steps working, but this is a common activity. So in summary, what do we recommend for your convenience? Use SSHFS to make the files on your EC2 instance look just like a local folder. Then you don't have to spend as much time typing in SCP to manually transfer files. You save time, it's more convenient. This also means that you can use your favorite editor to edit them locally. For example, now back here in VS Code, we see these libpng files from before, and I could start now, rather than trying to edit them remotely, I could start editing them with VS Code, which is maybe more convenient and has better search functions. And if I have to write test cases for this, now I can see all the if statements more clearly. Even though the files are stored remotely, I get to access them as if they were local on my computer. So use your favorite editor to edit them locally, and then run them remotely using the screen utility so that even if something goes wrong and your computer turns off or the network goes down, you don't lose any work. Okay. If you have any questions about this sort of material, feel free to post on the forum or come up and ask us after class. I hope these hints make things both more convenient for you and help make sure that you don't lose any work or end up having the wrong answers. Have a great day.